Hello. This is part 8 of creating a 2D platformer within Unity. It's been a long time. I'm just trying to remember what we did in part 7. I think we were establishing the finishing touches to our player. So what we're going to do is add the final little touch to our player today, as well as looking at setting up an enemy system within Unity. And we're going to start looking at inheritance classes. If you don't know what they are, do not worry. I will clearly explain what inheritance classes are and how to understand them and how to create your own. So what we're going to start off doing first is, if we play our game, you can see that we've got our idle working and we even have our animation working. I think that's what we did in our last session, but you can see if we walk backwards, we're walking, but we're not walking the other way. Our sprite isn't flipping. So how do we do that? So what we're going to do is come out of that and double click into our player script, and we're just going to add to this script to flip our sprite. Okay, so the first things first, or actually if we quickly look at Unity, look at our player, we can see, go to Sprites, we can see our sprite renderer here, and we can actually flip our sprite between our on different x-axes, which is brilliant. So this essentially means that we can call this out as our own kind of variable, call up flip.x and say we're going to flip that, and what's going to control that is our horizontal input, so our movement. So this should be really nice and easy and simple, just like transform movement, to figure out and write. So if we go back to our script, first things we're going to do is write it as a variable. So let's put it as a private, and what was it called? Sprite renderer, wasn't it? So that should pop up straight away. Where is it? There it is, sprite renderer. And we can just call this underscore sprite as our variable name. Cool. We then need to get the component within start. So we can say again, underscore sprite is equal to get component in children. So this is get component in children simply because if we look at Unity, we can see that sprite renderer is actually within a child to the parent of player within our hierarchy. So we need to tell MonoBehavior or tell Unity where to find our sprite renderer. So that's why we put get component in children, and then we can say sprite renderer. There we go. And encapsulate that and close that off. Lovely. Okay, so we've named it and we're saying where we can get our components. So within our movement, so if we stick that here, we can say, obviously it's if we move, isn't it? We don't want it just to randomly flip on our idle. So if our horizontal input is more than 0, we can say underscore sprite dot flip x, because we know we can find flip x because Unity specifies this under sprite renderer flip and x just here. So that's why that pops up with within Visual Studio. Flip.x equals false. So if we're going to the right, as this arrow says, or going in plus numbers, so 0 to whatever, beyond 0, our sprite won't flip. But else if, we can say, else if, oh, that was funny, why did that do that? Let's just clear this up. Why did that do that? That's not very nice. We can put else if horizontal input is less than 0, or we move to the left, we can say Again, underscore sprite dot flip x equals true, because this time we want our sprite to flip the other way round. Okay, let's save that and test this out. Back into Unity. Let's clear that. There's no major errors, so that's okay. And we should, if we press play, walk one way and be able to flip and walk the other way. Fantastic. That is working seamlessly. Lovely. Cool. And it looks good at the same time. Great. Lovely. So I'm going to quickly save that. That's all good. Okay, so now we've flipped our sprite. You know when you've got a really good video on your hands on YouTube when someone clicks on straight to PowerPoint to explain inheritance classes. So a little bit out of the ordinary with this, but I really wanted to explain inheritance classes as clear as possible to you. So you can watch a load of other videos on YouTube and Unity as well with this. So if you go to Unity, I think unity.com/learn, they have loads of different things and even kind of mini tasks that you can do and undertake to learn about inheritance classes. So this is essentially two scripts talking to each other, and where one is the main script, so is a parent, or in industry language is the base script, and the other scripts known as children, or the derivatives, or the derived from that main parent script are taking bits from that main script. So difficult to kind of understand that if I just explain that like that. So let's go into a little bit more detail. So what is an inheritance class? Inheritance within C# is a programming language which allows you to define a base or parent class, so a main base class that has integers, float, and all kind of methods, as it says here, specific functions of data or behaviors to a derived child that either inherit or override functionality. Okay, so if you're still not understanding, do not worry. Here's an example. So let's say the one in the kind of the peach or orange color, depending on how your eyes are doing. I've created an example here where I've got sharks. So this is kind of a blueprint of what defines a shark. So I've, just for argument's sake, created three different methods called teeth, gills, and fins. And they're kind of three main things that kind of make up sharks. Or if you are thinking of sharks, you think, oh, they've got gills, they've got fins, and they've got massive teeth, especially if you're thinking of a great white shark. So the parents of those, or the children of those three off the main parent are going to be a great white, a tiger shark, and a hammerhead shark, because they all have teeth, gills, and fins. Then within these specific scripts, we can add bigger teeth, smaller teeth, or bigger markings, or different size head, or something like that. We can then tailor these different scripts to off the parent one. So these can be totally different kind of enemies, for example, and that's what we've got here. So this is what we're going to be creating within Unity, where we've got our base enemy. So all enemies are going to have health, speed, a collectible when they've died, and an attack method. But we can have three different enemies. We've got enemy A, enemy B, and enemy C, just for an example. And again, all three of those children are taking from the main, are inheriting from their parent with health, speed, collect, and attack method. So what we're going to do is we're going to implement this into Unity and hopefully get a clear understanding of what's happening and how we can create a base script and how we can inherit health, speed, collect, and attack to create three other scripts. Okay, so first things first, what I'm going to do is, if I go on to Unity, I did actually download a enemy character. I haven't added him yet to here. Let's have a look in here. Download skeleton. Sprite sheets. Let's just grab that idle for now. Yeah, let's try and create a new folder. Let's create a new folder. So create folder, and I'm just going to call him skeleton. And then within here, I'm just going to add all of these sprite sheets. There we go. Fantastic. So there is my idle, and at the moment it's just one sheet. So I think these are 32 by 32. So if you have seen previous videos, you know what I'm going to do next. Essentially, I'm going to create these into multiples and click apply. We're then going to go to our sprite editor, which will then show our skeleton script, skeleton sprite sheet. Go to slice. Should I just do automatic? I'm going to go with automatic. Just cool. That's done a good job. I'm happy with that. So once I've clicked slice, I can click apply and click off sprite editor and make sure. There we go. So there's all my sprites. Lovely. So what I'm going to do is create an empty in my game. It's going to be there, I think. If I just click that, fantastic. He can stick there. I'm going to call him skeleton, and I might just do underscore enemy, so I'm aware. Then what I'm going to do is add another empty. I'm going to parent that. So I'm going to pretty much do the same setup as I have with my player and my sprite. So I'm going to name this sprite as well. Or let's just call it so it's all nice and clear. Skeleton sprite. Cool. Lovely. And then I can add, just like we did with the player, my first. Is that the first one? Can I add him to that? Will he go into that one? Lovely. Cool. So he's gone in there. My sprite render has popped in. I've just realised what I haven't done on this idle sheet, which is changed them to the unit of 32 and click apply as well. There we go. There he is. He's popped up. Layout order 0. I'm just going to stick him to the same as the player sprite, which was 20. So if I go, oh, it's created an even other parent, so I could probably just get rid of that actually, couldn't I? So if I take that into there, just delete that because it's already customly created one. It's done the job for me. 20, and what I can do is just size this guy up. Yep, that'll do. I'm happy with that. Cool. I'm just going to have him floating for now. Lovely. Fine. That's good. He's there. I know I can sort out his idle animation in a bit as well. But initially have your enemies set up. And what I'm going to do, I'm going to just do this for one example now, but within the game I'm probably going to create 2 or 3 different enemies to obviously show off the inheritance class. So now I'm set up and ready to create my inheritance class. Why even do it? Why can't we just create a script for every single enemy? Well, we essentially are, but we, just to avoid error, retyping, copy and pasting, is obviously the big one. I feel like a lot of people do, and that's why things go wrong within Unity, because essentially every script is different. So, but if all the fundamentals, if we have a quick look at the PowerPoint again, if all the fundamentals from the parent, like health, speed, collect, and attack, are working, you're going to have less issues. You can then have as many enemies as you like, all deriving from that main parent, and you don't have to retype anything, you don't have to copy and paste anything. You can quickly create a brand new enemy and not worry about a thing. It's easy as that. And that's essentially what we want here. Okay, so what I'm going to do is, what can I do now? Right, this, I'm thinking there's many things I can do. Let's go into scripts. And what I'm going to do is create a folder. And we're going to call this enemy. So everything that we're going to create for our inheritance class is going to be all in one folder. And and let's double click on this. And we're going to create a brand new C# script. Call this enemy. Capital E would be nice. Thank you. Lovely. So we've called that enemy. So what I'm going to do is double click onto this. So how do we set up our parent script, our main base parent script for our inheritance class? Well, it's pretty easy. All we need to do is look at this PowerPoint, and we can see that I've indicated that I want to do an integer for health, an integer for speed, integer for collect, and a method for attack. Okay, so can I just write that? Well, you can. It won't come up with any issues. So we could easily put in integer health, integer, I don't know why we've got that weird thing come up, integer health, integer speed, integer collect, and obviously we also can have our void attack method, just like that. Absolutely fine. Only differences here is when we're creating an inheritance class, access modifiers are massively important. Okay, so what I mean about access modifiers is your public, your private, your states essentially. And they're really important with inheritance classes because obviously we want our scripts to inherit, to take health, speed, collect, and attack from that. And if we don't specify that here, and you're not specific, they won't be able to read each other and understand each other. So what we need to do, so if we go back to this PowerPoint and have a look at access modifiers. So you've kind of hopefully seen this before and understand what public and private are, but there's a third one as well called protected. Okay, so to start off, there's public with methods, features, and variables created will be visible in both parent and child classes. Just like when we create something as a public variable, we can see that in our inspector within Unity. Private, again, the methods and features and variables in the parent but are not accessible in the child classes. Again, just like Unity, if we make something private, we can't see it in the inspector. Okay, so there's now this hybrid or protected version, which is a mix of both public and private. Both are accessible in the parent and child classes, but are not available outside of the scripts. So you could create a protected class or variable or method, something like that, just for the scripts themselves, just to make the scripts easier to understand or easier to sort of get round some maybe technical part that you're adding or something like that. I don't know, it could be anything, but it's important to know all three. For now, we're just going to do public because everything we want in our parent, we want our child script to see that. Okay, so if we go back on to Visual Studio, what we're going to do is make sure these are all public integers. So what we're going to do is just add public onto each one. Cool, lovely, 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 cool, awesome, that's great. What I'm also going to do is start and void. We don't need those. So, and we can just Command S and save that. So that's our main parent script created. So if we go back here, we can see that we have created this main enemy script. Okay, so one of my children is now going to be skeleton. So if we click on Unity and we can see I've got my skeleton enemy. Cool, let's create a script for him. Okay, or her, doesn't matter. And we're going to create a brand new script and I'm going to call this skeleton. Cool. So what I'm going to do is on my skeleton enemy as well, I'm going to add component, type in skeleton. There we go, and add that script straight away. Cool. Awesome. So what I'm going to do is double click onto skeleton. And at the moment, what I'm going to do is just delete, start, and update. At the moment, we can see that our public class skeleton is public, so it's visible in Unity and can be used. And that is a product of mono behavior. So everything that happens in skeleton, so whenever we write a normal script, it will always affect mono behavior. And a mono behavior is a part of Unity. And so if you're confused by this, everything that your script writes to goes to mono behavior, which affects movement, effects, particles, everything within Unity here. Okay, so we could put this script on a cube and make that cube move across our screen because it's moving because Visual Studio is talking to mono behavior, which is Unity. Okay, so, but we don't want that. We want skeleton to speak to enemy because it's a child, a product of enemy. So what we're going to do is actually delete mono behavior and write in enemy. There it is, pops up just like that. And what we're going to do is Command S or Control S on PC and save that. Then what we're going to do is go back into Unity, not PowerPoint, back into Unity. And what we can see, if we click on our skeleton enemy, straight away, there we go, skeleton script, and we have our health, our speed, and our collect. And there it all is. So because our skeleton script is now inheriting not from mono behavior, but from our own enemy script, which we have created that obviously has our health, speed, and collect. So we can do this for multiple enemies. Just create a brand new script, drag it on, and set our health to 100, our speed to 50, for example, just like that. So the beauty of this, so let's say this, I've created another enemy. So let's go create another empty, and I'm going to call this crab enemy. This is just as an example. And what I'm going to do is add another script. So what I can do is go create C# script, and I'm just going to name this crab. I don't actually have a crab enemy, but there we go. So go into my crab enemy, add my crab script. If I go on to this script, again, what I'm going to do is make sure that it is parented with enemy. Capital E, there it is. Command S, save that. And what I can do, once I go back into Unity, I can see that when I click on crab enemy, again, I have health, speed, and collect. But this is where we can now customize each of our scripts, our child scripts. Because if I look at skeleton, my skeleton's got a health of 100, speed, and 50, and the collect of 0. I can easily change crab to 50, 20, and 2. And the beauty of these scripts is that they're only inheriting, they're not taking numbers, they're not taking any kind of numbered variables from the parent. So we can totally create this as custom, as you can see here, that all the numbers are completely different. So creating completely different unique enemies, but at the same time saving us time because we're deriving from this main enemy script here. Okay, cool. I hope you understand that. Again, if you are a little bit confused or I've gone a bit too quick, I do apologise. I might just put this up on as a link for you to just kind of download and try and understand. I've also got extended research into inheritance classes, and this is a C# inheritance video created by Unity themselves. So if my rambling on hasn't made any sense, Unity have got their own videos, and that's the link there to it. that I can put it in the description below as well. Okay, I hope you've enjoyed this video, and I hope you have understood inheritance classes. Cool. See you soon.